So this is a 1-bit adder. It adds 1 bit to another bit, and it has a carry in and a carry out. So what we can see here is it has 2 inputs A and B, and a third carry in, and a sum bit out, and a carry out bit. And then it also has these 5 cross rods that communicate the information from the 3 inputs to the 2 outputs. So as with the previous gate, the off position is when they are pulled out in this direction. However, unlike the previous gate, this has 2 types of rods. These 3 input rods and the sum rod, as well as these 5 cross rods, have to be in the off position by default. So when you start using the gate, they have to be in the off position. But the carry out rod has to be in the on position when you start. That was the only way to make it with only 10 rods. So even though this is much more complicated than the previous gate, it is still much simpler than if I wanted all of the rods to be by default in the off position. Okay, let's do some math. First, let's add 0 to 0 with a carry in of 0. So we set the inputs A, B, and C in to 0, which they are currently. Then we push the control rods or the cross rods as far as they will go. And then we push the sum rod in the sum direction, in the 1 direction, and we push the carry out rod in the 1 direction, or sorry, in the 0 direction. And so this one is free to move. It's turned off now because there's nothing blocking it. And so the output is a sum bit of 0 and a carry out bit of 0, which is correct because 0 plus 0 carries 0 is in fact 0. If we now reset, so remember we have to push carry out in the 1 direction to reset it, and then we push all of these back. We can now add, let's say, 1 to 0. So 1 plus 0, carry in 0. We now push these rods as far as they will go. None of them moved. And so when we push the sum bit, that will turn on, and the carry out bit will turn off, which means we have an output of 1 sum and carry out 0, which is in fact 1. Okay, let's reset this. Now let's add 1 to 1, and let's do A and the carry in of 1 just for fun. Again, we push these. This one moved now. Neither of these moved. So now if we try to push the sum bit, it won't move, it's locked. And the carry out bit is also locked, right? So the carry out bit is on, the sum bit is off, that represents 2. Okay, now let's reset this. And now let's just add 1 to 1 to 1. So the output should be 3. So we have A and B are on, carry in is on. Push this, push this, push this, push this, push this. This moved now. So the sum bit turns on, and the carry out bit is locked in the on position. So the sum is 1, and the carry out is 1, which represents the 2's column. So 1 plus 2 is 3, and hooray, we have done some mathematics.